In this section, we're going to be taking a look at a slightly more advanced concept known as decorators. Now, the reason I'm showing you the power of decorators is so that you're aware of the functionality that exists in case a use case ever comes up. Now, you don't necessarily need to remember how to implement them with the exact syntax, but knowing that Python allows you to do this will make for an easier time in Googling a potential solution, especially if you know that decorators are a good option for your specific problem statement. Now, put simply, a decorator takes in a function, it then adds some functionality to it, and then returns the new function. So you can take an existing function, personalize it and add some new things to it, and then return the newly jazzed up version. Now, in programming, this is also known as meta programming, which essentially means that at the runtime of your code, one part of the program modifies another part of the program at compile time. Now, in order to understand decorators and how they work, there are a few things we need to know beforehand. So I'm going to recap some things first to ensure you're equipped with everything you need before diving into decorators. Okay, so let's begin. Firstly, we need to appreciate that everything in Python, from the lists and tuples you create to functions and even classes, they are all objects. Now, when we provide a variable name, put equals, and then assign it an object, what we are essentially doing is providing a name identifier which is then bound to these objects. So if I were to put A equals and then the string hello, the name A is bound to this string object. If I were to put B and set this equal to a list of integers 1, 2, and 3, the name B is bound to this list object. And the same goes with functions. So if I were to create a simple function where we put def greeting, and this function will have one parameter which we'll label as message, we can then put a colon and we'll simply print the message. Now here we've created a simple function object which we've named greeting. In other words, the name greeting is bound to this respective function definition. Now if we wanted to, we can have different names bound to the same function object. So if I were to put greeting and in brackets simply put the message hi, when I run this code cell, we get hi printed to the screen. No surprises there. But let's suppose we now assign a new name. For example, we put the name welcome and we set this equal to the same object as what the greeting name is bound to. So we can write welcome equals greeting. When we now call upon the name welcome, which we know is bound to the same function, and we pass in hi in the parentheses, we print out hi to the screen. So both of the functions produce the same output. And the explanation is simple. The names greeting and welcome refer to the same function object. Okay, so now pay close attention here because we touched on this earlier in the course, but you may have forgotten. Now, did you know that functions can be passed as arguments to another function? Now, hopefully you're thinking, yes, they can, Dean, because we saw this when we covered functions like map and filter earlier in the course. But this was a long time ago, so some of you may have forgot. So let's see an example in action. Functions that take other functions as arguments are also called higher order functions. So if I were to create two functions, let's first of all create a function called increase, which has one parameter labeled x, and we will simply return x plus 1 for this function. We'll then define a function called decrease, which once again takes in a parameter labeled x, and will return x minus 1, so we'll simply decrease the input by 1. We can then create a function called the operation, and inside parentheses we'll pass in two parameters. The first parameter will be in reference to the function that we want passed in. Now this will be either the increase function or the decrease function that we've just defined above. Now the second parameter will be in reference to the variable x, which is also used in both of the functions above. We can then have it so that this function creates a variable called result, which is equal to the function that we pass in, i.e. func, and in brackets we then pass in x, which is also passed into the operation function. We will then return the result. So if I now call upon the operation and in brackets put increase as the first argument, comma 5 as the second argument, when we run this code cell we get 6 returned, because we know that the increase function increases our input by 1, so it adds 1 onto the 5. If we put the operation and pass in decrease as the first function, and this time put in 85 as the second parameter, you can see that when I run this code cell, we get 84 returned, because we decrease our input by 1 based on the definition of the decrease function. So example aside, what we are doing here is passing a function into another function to perform some form of operation. In this case, it's increasing or decreasing the argument by 1. But let's now go one step further. A function can also return another function. So if I create a function called I'm_being_called, and then simply put parentheses and a colon, and then inside this function I create another function called I'm_being_returned with parentheses and a colon, I can have it so that this inner function simply prints the string hi, and then I can return the I'm_being_returned function within the I'm_being_called function. This may look slightly confusing, so let's just go through step by step. If I create a new variable called new_name and then set this equal to I'm_being_called with a set of parentheses, what we are doing here is calling the I'm_being_called function, which we know returns the I'm_being_returned function. So what we are simply doing here is we're bounding the name new_name to the function that's being returned called I'm_being_returned, which is returned because we've called the I'm_being_called function. Slightly confusing, but if we take a look at what the new_name type is by using the built-in type function, we can see that the new_name is an object which is of the type function. So we now have a function that we can use. What can we do with functions? Well, we can call functions. So if I put new_name and then put a set of parentheses, what do you think will happen? Well, if we do this, we get hi printed to the screen, because the I'm_being_returned function is the function that's bound to this new name, and we know that the I'm_being_returned function is defined with a simple print hi statement within the code block. Now what we're working with here when we type I'm_being_returned is what is known as a nested function, which is defined and then returned each time we call I'm_being_called. And this is an important thing to appreciate when it comes to decorators. Now the last ingredient we need before we dive into decorators is what is known as closures. Hopefully you're following along so far, so let's quickly take a look at closures in the next video.